Hi guys. All right, I'm about to share a PowerPoint with you about some more limit rules. Okay, these will kind of finish up our limit rules. All right, so let me see if I can get this PowerPoint to go. All right, on a good day. Yay, yay. Okay. All right. Now there are 3 special limit rules in your book that you're going to need to memorize. All right, and it says 3 special limits. All right, it's out of that same section that you've been in. Okay, so these are the 3 that you need to learn. Okay, and you can just memorize them. The limit of the sine of an angle over that same angle as that angle approaches 0, the answer is just 1. So if you've got that memorized and you see this form, you know the answer is just 1. Now it doesn't literally have to be x. It just means that this angle and that angle have to match. So if one is 2x, the other has to be 2x. If one is 5t, the other's got to be 5t. All right, if they don't match, we'll see in a second, you're always going to change the one on the bottom. You can't really mess with the one next to sine, but they need to match. All right, look at this one. The limit of 1 minus the cosine of an angle over that angle. And again, those angles need to match. If they don't match, again, you would mess with the one on the bottom. All right, and it's got to be approaching 0. All right, and this one's approaching 0, and it's 1 plus x raised to the 1 over x. That one equals e. All right, I was gonna see if I could find my book, but I'll have to look for it in a minute. Okay, so I'll double check in a minute with my book and see which page that is on. All right, so I'm gonna kind of flip over so that you can kind of look at it in your books. If you want to find it, it's in that section 2-3. And both of those are on page 89 in your books. So page 89 in your books. All right, so let me show you what I mean. What if you had the limit of the sine of 4x over x as x approaches 0? So do you see how those don't match? So if they don't match, I've got to change the one on the bottom to match the one on the top. So what can I do to x to turn it into 4x? Well, the easiest thing that I can think of is to multiply it by 4, but you can't go multiplying something by 4 on the bottom unless you also multiply by 4 on the top. Because remember what you're really doing right here, you know, this is kind of a, you know, just a way of writing 1. And by the identity property of multiplication, you can multiply anything by 1 and not change it. Now here's the key. Slide in the one you need and don't the one you do not need. So look what I did. The limit of the sine of 4x, well, what's 4 times x? Well, 4 times x is 4x. Now notice, all right, I've multiplied this 4 times that x, and that's where I got the 4x on the bottom. But I've still got this 4 on the top that I can't just get rid of because I don't want it. All right, so I multiplied out the bottom and I did not multiply out the top. Now, remember those limit rules that I went over the very first day that I said you still need to learn those basic limit rules because you're going to need them sometimes. Well, this is one of those times. I can take that number, remember, I can take a number and pull it in front. So that's what I do. All right, that was one of the first limit rules that we went over was if you have a number with a function, you can take the number and pull it out front. And then look, this one now fits this form up here. This angle and this angle match, and if x is going to 0, 4x is going to the 0. So because I have this rule memorized, I know the answer to that thing I circled is just 1, and 4 times 1 is 4. All right, here's what you cannot do. It's a coincidence that if you just take that 4 and pull it out front, you get the same answer. You can't break the sine of an angle into 2 things. It's one thing, all right? Now look at this one again. Same kind of thing. All right. This one looks a lot like this one, but it's got that extra 3. So I did this one. I could have done it the same way, but I kind of used another rule that said if you have a product, then you can separate them. That's the limit of the first one times the limit of the second one. Or like we said in the example 1, I could have just taken that 3 and I could have pulled it out front. Either way. But remember, the limit of a constant is that constant. And again, I've got this one memorized. That's that second one up here. So I know the answer to that is just 0. And 3 times 0 is 0. But see, if I didn't have this circled thing memorized to know it was 1, I didn't have this circled thing memorized to know it was 0, I'd be stuck right there. So it's going to be real important that you memorize these 3 in case you see them come up in a problem. Okay? Now, let's go look at this thing about infinite limits. It's kind of a misnomer, really. All they're doing is they're not changing the answer, they're making it a better description. Okay, look what it says. What's the limit of f of x as you approach 1 from the right, 1 from the left, and then just 1? And this is your f of x, 1 over x minus 1. So I graphed it. So that pink graph is the graph of y, or f of x, equals 1 over x minus 1. Okay? Now look what happens when you get closer and closer to 1 from the right side. So I'm over here. You know, 1 is right here where that asymptote is. All right, well, that's pretty close to 1. So it'd be about that y value, maybe about 2. If I get closer to 1, do you see how this y value is just shooting up and getting bigger and bigger and bigger? Now, you could write here, right does not exist. That would still be correct, because you're not getting closer and closer to a number. It's just infinity is a better description. It says that the limit there does not exist because the y values are getting bigger and bigger and bigger. So when it just says does not exist, you don't really know why. You just know apparently you weren't getting close to a single number. But when it's just getting bigger and bigger, instead of writing doesn't exist, a lot of times they'll start putting infinity, because that's really a better description. It tells you that the limit does not exist and why. The limit does not exist because the y values are getting bigger and bigger. Well, what if they had said, what if you just approach 1 from the left side? Well, again, 0, your y value right there is about 1. If I go to a half, that y value looks like it's below -1. If I get closer, do you see how now the y value is just going down, 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 down? So again, they could say does not exist, but instead they're going to say negative infinity when something like that happens. Because again, that's a better description. It still says that this left-hand limit does not exist, but it says it does not exist because the y values are getting smaller and smaller and smaller. Remember, -100 is smaller than -10, okay? Now, if they just said, what's the limit as you approach 1, they're not going to say positive, negative infinity. So if it doesn't match, remember, it does not exist. All right, so they're going to start putting infinity when the limit doesn't exist and the numbers are just getting bigger and bigger. And they're going to start putting negative infinity when the limit does not exist and the numbers get smaller and smaller. But if it's shooting up on one side and down on the other side, their best answer still just does not exist. Now, look at the difference here. Instead of it being 1 over x minus 1, what if it was 1 over x minus 1 squared? So do you see how this is the graph of this one? So if they said, okay, what's the limit, okay, of f of x as x approaches 1? It doesn't say what side. All right, it doesn't say what side, so I've got to come from both sides. All right, so let's go on the right side first. All right, well, if I do right, 1's right here again where this asymptote is. Now it's about that tall. So the y value is, I don't know, around 2. If I get closer, do you see how the y values are getting bigger and bigger and bigger? So from the right, I'm kind of doesn't exist because the y values are getting bigger. Well, what if I approach 1 from the left side? Well, again, that looks like maybe about 2, I don't know, 3, now I don't know, 8. It's getting bigger and bigger. So this time it's shooting up on both sides. So rather than writing does not exist, a better description would be positive infinity. The limit does not exist because on both sides, the y value is just getting bigger and bigger and bigger. So really the only difference is you can still write doesn't exist, But if it doesn't exist because the y values are getting bigger, then put positive infinity. If it doesn't exist because the y values are getting smaller all the time, like down, 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 put negative infinity. But if it's going, if it's getting bigger on one side, like over here, and smaller on the other side, your best answer still does not exist. Okay? So really, it's just kind of a clarification rather than a different answer. Now, they're going to use that idea to talk about asymptotes. So look what they give you. They give you this theorem, all right, in your books about vertical asymptotes, okay? And it's going to be in section 2.5 in your book. I want to double check. Section 2.5 in your book. So look what it says. Let F and G be continuous. We'll talk about that later. So no jumps, no gaps, nothing like that, on an open interval containing C. If there's an X value C, where the bottom equals 0, see G of C equals 0, and the top, see F of C does not equal 0, then X equals that number is going to be a vertical asymptote. Now, what's that saying? Here's what it's saying. If there's a number that will make the denominator equal to 0 that does not make the top equal to 0, then that number, then X equals that number is a vertical asymptote. So look what would happen here. Is there a number that'll make this denominator equal to 0? Yeah. When X is 3, that bottom goes to 0. Well, then I need to see you plug 0 in both places. Do you see plug 3 in both places? So do you see if you put a 3 in there and you put a 3 in there? If you do that, then you're going to get the numerator equal to 5 and the denominator equal to 0. So there is a number that will make the bottom 0 that does not make the top 0. So X equals that number that you plugged in is a vertical asymptote. Okay, but now I want to make sure we're clear about something. See, what numbers make this denominator equal 0? Well, if you factor that, it factors into X minus 2 and X plus 2, so you get 2 answers. Well, I've got to plug both of those answers in, and it's got to make the bottom 0 and not make the top 0. So when I plugged in 2, the top and the bottom went to 0. So this theorem does not apply to this number. When I plugged in a negative 2, though, for X, I plugged a negative 2 in there and a negative 2 in there. I got a negative 4 on the bottom and I got 0 on the top. So there was a number that made the bottom 0 that did not make the top 0. Then X equals that number ends up being your vertical asymptote. So it cannot make both of them 0. It's got to make the bottom one 0 and the top one not 0. If that happens, then the number that you plugged in, X equals that number, is a vertical asymptote for that graph. And so one thing you have to be able to do on your homework, they're going to give you some equations and ask you to find the vertical asymptotes. So notice what you do. You find all the numbers that make the denominator, the bottom, equal to 0. Those are what I call your candidates. They might be the answer. But if it makes the top and the bottom go to 0, no. It's got to make the bottom 0 and the top not 0. Then X equals the numbers that plugged in to do that. Those would be vertical asymptotes. So make sure you check them after you find your candidates. Now, on your first test next week, you're going to have a whole bunch of limit rules in addition to other kinds of problems, but the limit problems are going to be all mixed up. So remember, the first thing you do is you try to take the number and just plug it in. If that works, great, you're finished. If that doesn't work, we talked about 3 tricks. One is to factor it. Sometimes that helps. If you've got a root, multiplying the numerator and denominator by the conjugate of that root might help. If you've got a complex fraction, simplifying that might help. All right. You've also now got 3 special limits you can memorize. It might be one of those. All right. If plug it in doesn't work, if your 3 tricks here don't work, If it's not any of those special limits, then your best bet's to make a table and try to guess. So I just put some problems to kind of show you. See, the first thing I would try to do is plug 4 in for t, but it's going to make that denominator 0, so I can't do that. So I thought, well, I know how to factor, so let's try that. So sure enough, that t squared minus 16 factors into t minus 4 times t plus 4. Okay, and the t minus 4 is divided out. But remember, you've got to write me this note to guarantee me that you didn't just cross out 0 over 0 and call it a 1. The only way that would be 0 over 0 is if t equals 4, and this t approaching 4 guarantees me that t is not 4. So I've got permission to do that. That just leaves me t plus 4. Now I can take 4 and substitute it in for t and get an answer of 8. Okay, this one, again, if you try to take 0 and plug it in for x, that bottom goes to 0, so you can't do that. So factoring doesn't help. I don't know how to factor this, but I notice it's got a root, so I use the conjugate. Now remember what the conjugate is. This part stays the same. I just change the minus to a plus. And if you multiply the top by that, you got to multiply the bottom by that. Now remember what I told you kind of in that last video. The trick is to only multiply out where the root was originally. So this root was originally on the top, so I multiplied this top out. This root times this root just gave me 9 plus x. When I said this root times 3 minus this root times 3, those middle terms went out. And then minus 3 times 3 is 9. And then I did not multiply the bottom out. I just wrote down that denominator times that denominator. Well, see, the 9s divide out, subtract out, and that leaves me just x on the top and x on the bottom. And those divide out. But again, I've got to guarantee me that x approaching 0 guarantees that x is not 0. So that just left me 1 over this 9 plus x plus 3. So now I can take that 0 and I can plug it in. All right, and I got 1, the square root of 9 is 3, and 3 plus 3 is 6, so I got 1/6. Now I just try to take pi over 3 and plug it in for x. So I put pi over 3 in place of x, and it worked. So sometimes just plugging in the number works. I just need the secant of 2 pi over 3. Now remember, you need to know what quadrant you're in. So remember, you take your calculator and figure out that that's 120 degrees. Well, 120 degrees is in quadrant 2. Remember that secant is the reciprocal of cosine, and cosine depends on x. And in quadrant 2, x is negative. So the first thing I would do is put my sign down. Then I'd go find my reference angle. So remember, in quadrant 2, your reference angle is 180 degrees minus your given angle. All right, so 180 minus 120 gave me this reference angle of 60. So that's where I got 60. So I looked at my 30, 60, 90 degree triangle, and secant, remember, is hypotenuse over adjacent. And 2 over 1 ended up being 2. So that's how I got that -2. So just plug in the number in, if I can just plug the number in. Okay, and I got a couple more just to look at real quick. Mostly you have to just practice them. Okay, look at this one. All right, so I look at this one and I'm trying to decide what to do. And I think, okay, just take the number and plug it in. We'll see the bottom goes to 0, so that doesn't work. All right, so then I think, well, there's nothing to factor, so that doesn't work. I think about conjugate, but there's not a root. It's already a pretty simple fraction. I do not know what to do. It's not one of those special limits we just went over. So my last thought is I'll just make a table and see what happens. So, here's my x and here's my y. So, if you try to put 0 in, the absolute value of 0 over 0 is going to give you an error message on your machine. So I'm thinking about 0, so I've got a negative numbers over here and positive numbers over here. So I picked a number pretty close. I picked a -1/10. So I need the absolute value of the -1/10 over that -1/10. Well, the absolute value of the -1/10 is a +1/10. And a +1/10 divided by a -1/10 is just a -1. That's a number over itself, but one's positive and one's negative. Then I got even closer, -100. So the absolute value of a -100 with a +100. And then that negative 100 showed the bottom. So again, I got a -1. So I started noticing no matter what I put in over here, I kept getting -1 for the answer. But remember, you've also got to come from the right side. Maybe I was thinking, oh, maybe the answer is -1. What happens when you're over here, like maybe a positive 1/10? Well, see, the absolute value of 1/10 is just a positive 1/10. And 1/10 divided by 1/10 is not a -1, it's a +1. I got a little closer, 100. But see, I got a +1. So I'm not getting the same answers on the left side that I got on the right side. So my answer is does not exist. You know, these numbers right here were not getting closer and closer to being the same number. Doesn't exist. See, I can't take 0 and plug it in. That bottom goes to 0. I couldn't factor it. There's no conjugate. It's simple. Then I went, oh, wait a minute. I think that's one of those special ones I learned. But I need these two things to match. So if they don't match, I've got to turn this one into this one. So I thought, what's the easiest thing to do to turn t into 5t? Well, to multiply by 5. But if you multiply the bottom by 5, you got to multiply the top by 5. So I went ahead and said 5 times t and got 5t. But again, I've still got this 5 on the top. I can't get rid of it. So I had that one of those rules that said that you could take a number and just pull it out front. Or I could have said the limit of this times the limit of that, either way. But now look what would happen right here. If you don't have this memorized, then you're stuck. You've got to have memorized that the limit as t approaches 0 of the sine of the angle over that same angle is 1. You know the limit of a constant. Well, 5 times 1 is just 5. But see, if you don't have these special limits memorized, you're going to get to a certain point and not be able to go any further. So start reviewing those limit rules, getting ready for your test. And we'll talk about your test when we meet on Zoom. Okay, but it's all the stuff off that algebra trig review sheet. All that's fair game. All of your limits. You've also got to be able to do a limit from a table, from a picture, and using your limit rules. Okay, you've got to be able to do me all those other kinds of problems that we've gone over as well, like the trig problems, the inverse trig, like what's the arc sine of a -1/2, you know, find the domain of this function, all those different kinds of problems, those summation formulas, you know, but no, that's a different class. Sorry, no summation formulas, scratch that. Okay, so you've got to be able to know all the things that we've gone over. We'll talk about that when we do our Zoom meeting though. So there's homework posted on Moodle that I want you to go try. Okay, so when I see you on Zoom, we'll talk about your first test, which is going to be next week. Y'all have a great day.